Alright guys, this video is going to be going over both assignment number 4 and number 5. Alright, so I got a couple questions on all sorts of different problems, so I thought I'd just make a video going over each one. Alright, so for number 1 here, if we're given the two zeros of a quadratic function, we're given zeros of -3 and +5. Right, and of course zeros are just, again, synonyms for x-intercepts or roots. So we know our parabola is going to pass through those 2 points, and we're looking for the equation of the axis of symmetry. Right, we should also know the axis of symmetry is directly in between the two zeros. So to find the axis of symmetry, we can average our two zeros. We can average -3 and 5. So to average two numbers, we add them up, divide by 2. That's going to be 2 over 2, which is 1. So there is my axis of symmetry, x equals 1. Right, if I draw this on the graph, x equals 1 is over there. Right, we can see that this line is the same distance away from 5 as it is from -3. Right, they're both 4 units away. Alright, number 2. When an apple is dropped from a 256-foot high tower, we get that function to model its height in feet after t number of seconds. Determine algebraically when the apple hits the ground. Right, so when something hits the ground, we know we're going to set our function equal to 0. Right, because when it hits the ground, the function here is a function for the height. Right, so when something hits the ground, its height is going to be 0. So I'm going to make h of t equal to 0 equals to -16t squared plus 256. Right, we're just finding the zeros or the x-intercepts and solving for t here. This is a quadratic, right? It's equal to 0. We're always going to factor out a GCF first, if there is one. So in this case, let's factor out a -16. Right, t squared and 256 divided by 16. What is that? I think that's 18. Double check. It's 16 minus 16. Right, and so 0 equals -16. This is a difference of two perfect squares. T plus 4, t minus 4. Right, t it off. And we get at time equals -4 seconds and time equals +4 seconds. So of course the negative doesn't make sense. We're going to reject that. And it's going to hit the ground after 4 seconds. Right, something else you could do. I know it says algebraically, but if you wanted to check your answer at least graphically, you can pull up Desmos or your graphing calculator. And let's graph this function. So y equals -16 x squared. What was it? Plus 256, I think. And if I adjust the scaling here, right, we can see those zeros we found, -4 and +4. Right, that's the initial height of the apple at 256, and then drops down and hits it after 4 seconds. Alright, so number 3 here. Michael drew a ball into the air from the top of the building. Its height is modeled by that equation, where t is the elapsed time in seconds. Graph this equation on the set of axes below. Alright, I would recommend typing this into your calculator and pulling up the table, right, Control T, and plotting all those points. Yeah, so let's actually do that first. So if you do that, you should get the point 0, 64. And let me actually graph this myself. -16x squared plus 48x plus 64. And I'm going to change this into a table. So you got -1, 0. We don't need that point. We got 0, 64. 1, 96. 2 comma 96. If we keep going, we got 3 comma 64. And 4 comma 0. So, if you see the symmetry, right, you're going to know our vertex is going to be at 1.5. Right, but before I apply any points, I want to do as much as I can algebraically. All right, so 3A here. Find the zeros of the parabola algebraically. When does the ball hit the ground? So again, if we're looking for zeros, we're going to set our height equal to 0. Negative 16t squared plus 48t plus 64. All right, let's factor out that negative 16. T squared, what is that? Minus 3t minus 4. All right, we're left with a trinomial in the parentheses now, which we can factor as t minus 4, t plus 1. Negative 16 times that quantity. And teeing it off, we got zeros at t equals 4 and t equals negative 1. So just like from the points on the graph, right, 4 comma 0, right, that's when it hits the ground after 4 seconds. All right, what is the initial height of the ball? That's the height of the ball at the very beginning, or in other words, at time equals 0. So if you want and you plugged in a 0 into our function, we plug in a 0 here for t, that's going to equal 64. So I'm going to write it as h of 0 equals 64. That's the initial height. If you look at the graph, yes, of course, we also have the point 0 comma 64. So our initial height is 64 feet. And this didn't ask us to find the vertex, but let's go ahead and find the vertex just so I can plot it more accurately. So I know my vertex is going to be on the axis of symmetry here. So having these two zeros, again, I can find the axis of symmetry by taking the average of those two numbers, right? Or you can do negative b over 2a using the original equation. If I average the two zeros, I get 4 plus negative 1 divided by 2, which is 3 over 2, which is 1.5. Right? And we already know that from my graph also. Right? Our axis of symmetry is going to be right here at 1.5. So if I want to find the vertex, I'm going to plug in a 1.5 to get the height of this ball at 1.5 seconds. So h of 1.5 would be negative 16 times 1.5 squared plus 48 times 1.5 plus 64. All right, if I type that into my calculator, it looks like this is equal to 100. So that's the vertex right there. And that is what the height of the parabola is going to look like as a function of time. All right, C, this is a good throwback question. Determine the average rate of change in feet per second from when Michael released the ball. So when did Michael release the ball? At time equals 0. So in other words, from this point, 0 comma 64, to when the ball reached its maximum height. So when did it reach its maximum height? After 1.5 seconds. That's until 1.5 comma 100. So average rate of change is the slope between those 2 points. So we can do 100 minus 64, right? Change in y over the change in x. That'll be 1.5 minus 0. And that's 36 divided by 1.5, which is equal to 24. Right, let's think of the units. On top was feet, on bottom was seconds. So the average rate of change is 24 feet per second. All right, and down here, just some quick practice solving equations. Right here are our steps. We're going to get each into standard form and set it equal to 0. So in this first one, right, subtract 2x from both sides, get it equal to 0. Look to factor out a GCF. There's a GCF here of x. So x times 3x minus 2 equals 0. Take a look at what's left. Is inside that parentheses, is that a dots? No. Is that a trinomial? No. So we're done factoring. We can use zero product property now. X is 0, or 3x minus 2 is 0, right? Because if you have something times something else equal to 0, then we can set either part equal to 0, and both of those will produce solutions. So solving this equation, 3x minus 2 equals 0, 3x equals 2, and x equals 2/3. Alright, so I'm just going to go semi-quickly do the rest. This one, again, set it equal to 0. Let's minus 1 on both sides. Look for a GCF. No GCF. Is this a dots? No. Is this a trinomial? Yes. Is a equal to 1? No. A is equal to 6. Let's use AC method. Right, 6 times negative 2 is negative 12. What multiplies to negative 12 adds to 7? What is that? Oh, I see what I did. This is positive 2, not negative 2, sorry. So what multiplies to positive 12 and adds to 7? 3 and 4. Right, so we've split the middle, 3x squared plus 3x plus 4x plus 2 equals 0. GCF of the first two terms is 3x. 2x plus 1. GCF of the next two terms is a 2. 2x plus 1 equals 0. Factor by grouping, they have a 2x plus 1 in common. 3x plus 2 equals 0. Tee it off. Solving here, x is negative 1/2. Solving here, x is negative 2/3. Alright, I'm going quick here, but we've done this so much that I'm hoping this is alright. Alright, please check your work though. Here, distribute x squared minus 2x equals distribute negative 3x plus 6. Again, we want this in standard form and equal to 0, so I'm going to add 3x to both sides. That's going to give me plus 1x. Subtract 6 from both sides. It's going to give me minus 6 equals 0. This is a trinomial where my a value is 1. So I just need two numbers that multiply to negative 6 and add to positive 1. And that's going to be positive 3 and negative 2 equals 0. Teeing it off, we get solutions of negative 3 and positive 2. Right, and for letter D, factor this, GCF of x. We're left with x squared minus 4. X squared minus 4, that's a dots. That's going to factor x times x minus 2. X plus 2 equals 0. Teeing it off, we get x equals 0, x equals 2, and x equals negative 2. Alright, I think I'm actually going to make assignment number 5 into a separate video, just so you can skip straight to either this assignment or the next one if you need help with something. Alright, so I'll be right back. See you guys soon.